Long before we started debating the role of AI in the classroom, the flaws in our assessment systems were already visible. We have decades of research and pedagogical theories from figures like Maria Montessori, yet institutional testing continues to prioritize the needs of the system over the needs of the learner. Schools maintain this model because it is logistically convenient. A test is easy to scale, inexpensive to administer, provides a simple numerical data point that is easy to defend to an administrative board. In the classroom, this creates a disconnect. A generalist teacher, often working outside their primary area of expertise, is forced to use a rigid rubric to measure understanding. They end up looking for specific keywords rather than checking for actual subject mastery. The current model functions as a dead end. It measures how well a student can comply with the mechanics of a test, rather than providing a clear picture of what they actually know. Escape rooms recently entered the educational conversation as engagement tactics, brief activities designed to break up a curriculum. But when engineered with the help of AI, these rooms function as something much more rigorous. This approach traces back to Kyoto in 2007. A publisher named Tako Kato was watching a classmate play a digital point-and-click game and began wondering if that same sense of logical discovery could exist in a physical space. His first real escape game had a surprising outcome. 149 out of 150 participants failed to get out. Despite the failure rate, the intensity made it an immediate success. The engagement wasn't driven by the win, but by the structure. The game functions through a sequence. Solving one problem yields the specific information required to access the next challenge. This architecture forces a demonstration of mastery at every single stage. Because you cannot see the next objective without resolving the current one, the physical progress of the student becomes the evidence of their understanding. In a classroom setting, an entire unit of work can be placed within this framework. The test is still there, containing the same rigorous questions you'd find in a traditional exam. But it's no longer a final verdict. It becomes an entry point. Resolving a challenge allows the student to move forward. This creates a diagnostic loop. If a student reaches a barrier they can't solve, they immediately pivot into a short, focused workshop on the specific material they missed. They learn the missing skill, and then they return to the challenge to try again. This transforms the classroom environment. Students work through problems at their own pace, and because the challenges are built as sequential gates, a student hitting a wall identifies exactly which subskill they haven't mastered yet. By framing the evaluation as a series of puzzles, we change the student's relationship with failure. Getting an answer wrong isn't the end of the process. It's simply the data point that shows them where they need to focus next. Adopting this system makes the assessment student-centered. It requires learners to demonstrate the path they took to reach a solution, rather than just providing a finished answer. The evidence of learning lives in the process, in the verbal explanations, the reflections, and the ongoing portfolio they build while navigating the room. Modern assessments are typically designed to be one-off events that reject iteration. This model assumes that repetition and refinement are the most important parts of the learning cycle. We can see the learning in the physical trail left behind, the initial drafts, the moments where a strategy had to be revised, and the explicit points where a student had to backtrack to find a new connection. When the visible record of problem-solving becomes the accepted proof of knowledge, the process of getting to the answer becomes more valuable than the final grade itself. AI acts as the engineering partner in this process. A teacher can use it to align each specific layer of the room with a curriculum goal, ensuring that the diagnostic loops are built into the logic from the very beginning. In this model, the room itself serves as the rubric. Because the physical structure requires a demonstration of skills to progress, the evidence of learning is embedded in the design, making the results easier to present to school leadership. To start, choose a single unit and ask an AI tool like Claude to help brainstorm the logic of a room. Don't worry about designing the whole experience at once. Focus on what a student needs to prove to get through the first door. Build the room on a small scale and run it once to see where the logic fails. Seeing where students get stuck provides the most useful data on how to refine the curriculum. Try this with just one class. When you remove the fear of getting it wrong, you see exactly what your students are capable of achieving.